have my notebook ready with me. I've already kept the focus on the screen, on the laptop screen, so that you guys can see, okay, the notes properly. I do need a ball pen for this to revise. Let me find my ball pen. I have a lot of pens, but whenever I need to study, I won't be able to find any of my pens right now. I hope my voice is reachable, audible. Okay. So I also need to see side by side what's going on this. The date is today February 22, I guess, 2026. That is. Okay. So first of all we have is RTH, which is right hand thumb rule. So right hand thumb rule means we'll be having thumb and we have a palm. So thumb and palm. I don't know if this is visible. Yeah, so we have thumb and palm. So which this thumb gives the direction of the current and palm. See, these are magnetic fields. So thumb and palm. Okay. So that is what we have here, is that in right hand thumb rule, the thumb gives the direction of current and the palm gives the direction of magnetic fields. So how does it work actually is that, if you focus on this part, you can see we have a wire in which current is flowing on. So this the wire, this is the wire and the current is flowing on. Okay. So if the current is going in the upward direction, okay, so imagine this is your thumb and these are the magnetic fields and the thumb is going up. So basically your magnetic fields are circling like this. It means the magnetic fields are coming towards this, and if you see, it is going out from here and coming towards here. So whenever an arrow, if you imagine an arrow which comes towards you, you can only see the point of the arrow. But when the arrow is going away from you, you can see the cross. So that is how we make point dot for the coming, what do you call this? Inwards, it's coming towards you, otherwise it is outwards. Okay, so that is how we get this. Now we need to determine the direction of the magnetic field here. So determine the magnetic field at P and Q. This is the direction of the current. It means it's coming out from this side. Okay, and this is going inside here. So this is the direction of the current. This is the point P and this is the point Q. Then it's coming and going like this. The similar goes one for this. It's coming out and then going in. Okay. So now we have two, what you call, what is this, current coming outwards. What is this point P? Okay. So this is this. Okay. So this third one is a tricky one if you understand this. In this they have shown the direction of the current in like that. That current is coming towards you. Okay. So current is coming like this towards you. So how will be the Q? Now Q will be going downwards and P will be going upwards. And the similar case is the fourth one where the current is going in this direction. So if the current is going in this direction, then Q will be going upwards and P will be going downwards. Next is the Biot-Savart's law. Okay. So Biot-Savart's law, what does it give us? It calculates the magnetic field and its direction. So here we study is that magnetic field is produced due to the current element. Okay. So because of this law we get the formula where basically we get a relation between how is magnetic field generated due to the current element. So whatever the parameters will be involving, which will be affecting magnetic field, is that we have a constant value, okay. Also we have the length of the wire, which will be there, the radius of the wire plus the current element. So this is a small wire, this is the wire, and we have taken a small section of the current from here, and then we measure the distance r from the point. We want to calculate the magnetic field and what is the current flowing in it. So we take a small vector form and then we do integration, and that's how we get the formula here. Okay, so in which there is a cross, dl cross r, where we have r cube. Remember, this is the vector form of the Biot-Savart law. But usually whatever the formula we use, cross, if we remove cross, we can put sine theta. So we put sine theta and we get r square, okay, because r and r gets cancelled. So we get a scalar form of this, which is scalar form of this Biot-Savart law. So we have two forms, vector and scalar. And then we have a permeability, this mu naught. I think it depends upon the medium, okay, and इसका जो value होता है, that is 10⁻⁷. Basically mu naught is 4 pi into 10⁻⁷. Okay. Wait, let me write this down. I am actually revising it with you guys. We have one vector form in this, which is mu naught upon 4 pi I dl cross r upon r का cube. We have mu naught, which is 10⁻⁷, this side, and we have a scalar form, mu naught upon 4 pi I dl sine theta r square. This is the scalar form. Okay, the next thing here we are discussing is that the magnetic field is zero if the point is at the point itself is lying on the current carrying element. Okay, so if the point where you are checking the magnetic field is itself on the wire itself, then the theta, the angle between the point and the current element, becomes zero. So sine 0 is 0. So that's how you get magnetic field 0. Okay, so at the axis of the current carrying element is 0. Because theta becomes 0, sine theta, sine 0 becomes 0, so B becomes 0. Then is the direction, which we have already discussed with the right hand thumb rule. You can apply it and you'll get it. Then we have is units of magnetic field. Let me change this color, it doesn't look good. So now this is units of magnetic field. Okay. Okay, there is a formula which you will be studying in future, which is BIL, the force is BIL, BIL, basically. So from there we can derive the direction, SI unit of this magnetic field, which is basically, if you calculate BIL from here, it is F upon IL. So F is Newton, I is ampere, and L is meter. So this becomes Tesla, which is Newton upon ampere meter, and this is Weber meter square. Okay. Next is to calculate magnetic field at point P. Now if you see here, the magnetic field we are calculating from this point and this point. Okay, so if this is A and this is B and this is the current carrying wire. Okay, so the point P is there. Distance between both the wire is A. From this to this and from this to this is A. Then what is the formula for magnetic field is that you get two different angles now. Okay, so this is theta 1 and this is theta 2. So that's how you get this formula is. There is no derivation that I've written. I've just directly written the formulas. If we are talking about two ends, then it's basically theta 1 plus theta 2. But if they tell you that one end is fixed, something like that, then you consider one. I'll tell you. Wait. So basically, you remember this formula because this is the important formula. It's actually very important formula. This is for a finite wire. If you get an infinite wire, there one of the angles become 90 degrees, so one of the sin theta will disappear. The rest of it will remain same. So here, one we have a Biot-Savart's law, okay, and one we have magnetic field at the axis of the current carrying wire, which is 0. The other one we are discussing is the magnetic field by a finite wire, where we get two sin thetas, correct? So B is equal to mu naught 4 pi I by A sin theta 1 and plus sin theta 2. We'll get another case where one of the wire will have an infinite end, correct? So from the figure shown, the magnetic field at point P, if current is 10, A is 70 centimeter, theta 1 37 and theta 2 53. So how will you calculate the magnetic field? If we just solve this, you guys can also solve side by side. We are given all the parameters, we just have to substitute. But the main problem here is everything is given here in centimeter, correct? We need to convert that into meters. Make sure to give attention to such points. Just don't directly go and dump to the question. And this is an ampere and we want everything in SI units, correct? So we have this formula for a finite wire. Because I've already mentioned that from the figure and you can see, correct? So how do we get this now? So you need the formula. So your B is equal to, you can replace this mu naught by 4 pi is 10 raised to minus 7. I is already 10, but A here is not 70. It's 0.07 because of the conversion into sin 37 plus sin 53. There's a very common triangle one, there you get 37, 53 ka values. I'll share it with you guys and you can study how you get the form values as 3 by 5 and 4 by 5 because of the triangle only you will get those values and you can substitute this. So sin 37 is 3 by 5 and this is 4 by 5. Okay. Oh, pi is theta in centimeter. Shouldn't we dating or something like that? Oh. Okay. So now you do kata PT. Basically, this becomes 7 into 100. Okay, this is plus. This becomes 7 by 5. So this becomes 7 to minus 7 into 10 into 100 into 7 by 7 into 5. This becomes 2. 2 into 100. This becomes 5. This becomes 7 into 1. So now you can get answer to this from 2 and 10 raised to minus 6 Tesla. Okay, this we have done. Next is use Biot-Savart's law to obtain expression for the magnetic field at the center of a coil. bent in the form of a square of a side 2A carrying current I. Okay. So basically now we have a square. Okay, and every side of the square is carrying current which is of 2A length. Okay, and we need to find in the center what is the magnetic field. So basically we'll take one scenario. This becomes a finite wire. Okay, and this is P. So what will be the angle? So here we know in square the angle is 90 degrees. So this half angle becomes 45 degrees. The same goes with this. So both the thetas we get is 45, 45. Correct? I. Now if we talk about I, it is saying current is I only. But the side they are talking is A. But we need this A, the actual, the center se hota hai. So if this proper is 2A, then the half becomes A. So that's how we get A here. This becomes 2 by root 2. And that's how we get one point, that is B. Okay. Now we need to find because of this side and this side. Now because all this is symmetrical, so all the B1, B2, B3, B4 will be similar. And that's how we get 4B by B1. And when you substitute 4B1, you get this. B net is equal to root 2 B0 pi I by 8. Next is because of the triangle. Okay. And we need to find it at the center. Now because this is an equilateral triangle, so angle here will be 60. So the 1 theta 1 becomes 30 degree. That's the main point. This becomes 30 degree. What is the length? Half the length, the side is 1 meter. So this becomes 0.5, but this doesn't matter. What matters is this length. How to find this length now? That's the main question. Also, why have to take on? So we also know at one point, we take theta from here. Okay? Not from here. Okay? Here, if you see, we need to find theta 1. We know this is 90. And this is 30. So what will be this angle? 60. Remember this point because I forgot. That's why you get theta 1 and theta 2 as 60 degree. Okay. A will become 0.5. And I think what else is there? I is already given 10. A is, okay, we need to find A actually. A is this point. So how do you find A? Is you are already giving 0.5. This is 30 degrees. So how do you find this? You apply tan 30. And tan 30 gives you 0.5 by root 3. That's how you get this value. Substitute and solve. Remember to make it into 3 because it's an equilateral triangle. This is another case of infinite length or long wire. Long wire or infinite case. Okay. Also guys, this is my quick notes wala notebook. I think I have made this. Yeah, this is magnetism ka short notes. These are all the formulas. So I think we are here right now. We've covered these formulas. We are here right now. Oh, it's very colorful. But that's how I like it. Okay, I was drinking water. So basically now we have a straight wire where both the ends are at infinite. So when it is at infinite, so the point becomes 90 degrees. It becomes almost like a parallel kind of situation. So both the thetas are at 90 degrees. This is for when both the ends are at, wherever it's infinite, it is 90. You just remember that. So this becomes sine 91, 1, 1 plus 1 is 2. So you just add a 2 here. No need to do kata pt. Okay. Otherwise you will not be able to substitute here 10 to the power minus 7. So it is very important to keep this 2 there. Okay. So just remember this formula. Now if they say only one end is finite and one end is infinite, so you will only substitute one as 90 degree and other as normal theta. You need to calculate. And remember again, theta is here, not here, because in the previous questions I was considering theta to be here. Okay? We need to make sure the point, small points does not take away our marks. In magnetic field is kind of an important chapter actually. Okay, next. The magnetic field at a distance r from a long wire, again long means infinite. Carrying current is 0.4 Tesla. They have already given the magnetic field, they have given current as I. Find the magnetic field at a distance 2r. Okay. So now because I have mentioned it is a long wire, so basically the formula becomes 2I upon 8. So where D, if you see, if everything is constant, D is inversely proportional to 1 by 8. If the B distance is double, that is 2r it becomes, then the B becomes half. Correct? So it will become B by 2. This is basically, if it is 0.4 Tesla, this will become 0.2 Tesla. That's your answer. What's your time right now? And what are your expectations and how much time will you be able to cover this? I don't know. I'll try to cover before 9 at least. I'm already at 7:30 and I'm taking a very long time. But till now we remember the formulas, right? Okay. Two very long wires, straight and insulated wires are kept at 90 degree angle from each other in X and Y plane. So now again, two long means infinite. So they kept an intersecting point 90 degree to each other. So one is in this direction. Sorry. How do we erase this? So one is in this direction and one is in this direction. Okay. Get it? In an XY plane. So this is a XY plane. As shown, these wire carries current of equal magnitude. Both carry current I. Okay. Net B they are asking at the point B. This is point B. P, sorry. This is going this side. Both are infinite. Here one thing we need to check is the direction. So how will you calculate direction for this one? If you consider the second wire, okay, first we'll consider the first wire, which is this one. The current is going up. So this is coming outwards and this side is going inwards. So this is inwards, and due to the second wire, this is coming outwards. So when both of the magnetic fields, if you will calculate, both will get the same magnitude, but the direction is different. So what will happen? Takrav. It means they'll cancel out each other's effect. So the net magnetic field will be zero because of the direction, not because of the magnitude. Okay, remember this one. Where do we expect the result magnetic field to be zero? Where do we expect? We have two wires. We have point A, C, D, D. In this again you need to calculate the magnitude will be same direction. Because of direction we need to see where it will become zero. So the one direction is this side and one direction is this side. direction is same, so it will not be 0. Okay. Two identical long conducting wires AOB and COD are placed at right angles to each other with one above the other such that O is the common point for the two. They carry L1 and I1 and I2 respectively. Point P is lying at a distance D from O along the A perpendicular to the plane that they wire the magnetic field. Basically this is the condition, and in XZ the sun both the wires are lying, and this is point P, and they have given this bi-directional height of this. Okay. So you will get some magnetic field B1 and then B2 and then B net. Okay. Of course, again these are long wires, so you will get some KI1 and this will get KI2 because the current is not same in both. Okay. Now you have to calculate B net, which will be under root of B1 ka square. Basically you are applying the superposition wala principle, and that's how you can just substitute. Everything is common, just substitute KI1, KI2, and that's how you just get an end result. It's a simple one. A semi-infinite length one is the one where one length is infinite and the other one is finite. So basically, here it will not become 2, it will be simple I upon A, or you can say that it is जो finite वाला का by 2 कर दोगे, so this will become this. Circular loop. Wait, let me see what are all topics are there. मुझे तो obviously create हो रहा है, but I don't know, this chapter is kind of good only. There are many formulas, but you can remember those formulas, not a big deal. These are easy only. It's very similar to the current electrostatics wala chapter, and more than that I find this easy for some reason, I don't know what it is. But you do have too many things here. Oh, dipole moment and stability and not applying physics system. Okay, next is magnetic field at the center of the current pole. Okay, so the magnitude will remain same, but the direction will keep changing. You just need to remember this. This one you need to learn. Here, 4 pi gets cancelled because it's a circle. It's a circle, so 4 pi gets cancelled, so only 2 becomes there. Okay, just remember this one. This formula. Only for the center point I am talking in the circle. The 2 pi gets cancelled. Sorry, the 4 pi. And instead of 4 pi it becomes 2 pi. Okay, अगर सिंगल लूप नहीं होगा, coil of n turns होगा, तो you multiply n with the formula. This is something you need to remember for everything in this chapter. यहाँ पे n turn आ जाए, वहाँ पे ये n आता है. ये आपका formula पता है ना, small n by n. Okay. A long wire carrying a steady current is bent into a circular loop. एक wire उस loop में कर दिया 1 turn, so n becomes 1. The magnetic field at the center B. Okay, if it is n turns now. Okay, so ये बोला. So because of 1 turn, the magnetic field will be mu naught by 2 I upon R. Okay. Now it has n turns, so basically it will become B dash and into n. इसका जो लेंथ होगा वो होगा 2 pi R, but इसका जो लेंथ होगा that will become n into 2 pi R. So from here this R becomes n into R. Okay. So B dash upon B becomes n upon R. Because the only difference between two is this R and this R. nR upon R. You put B dash upon B. Okay. cancel. I R आ जाएगा NR. Okay, NR आ गया नीचे. So already N upon R. So N square R and N square. So that's how you get N square. The magnetic field of a given length of wire for a single turn coil at center B, and then the value for 2 coils. Now you already know that B dash is equal to N square into B. It's N square into B. So now if they are given 2 turns, so how much it will become? 4 times the B. So this becomes an important formula. This is something which they can ask, I feel. 2 similar coils of radius R are lying concentrically. Now the radius will be same with the planes at right angles to each other. The current is different now. One is carrying I and the other one is carrying 2R respectively. So the resultant magnetic field will be. So here you will see the B2 will become 2 times of B1. Now we want B net. B net will be the under root of B1 का square plus B2 का square. And when you solve, so this 2 becomes 4. So 1 plus 4 is root 5. So basically root 5. An electron moving in a circular orbit of radius R makes n rotations per second. The magnetic field at the center has a magnitude. Guys, just give me 5 minutes. I want to read. No, I don't want to see how much did we cover. There are 52 pages. I don't want to cover the But yes, if we see from the quick revision part, magnetism. Ice cream. So I'm going to have to video of this as well one day. I don't know, I'm getting heart attack. You are able to find my magnetism. Yes. There are people. Come on, we have done one strip. We are here guys right now. And this 4 strips basically. 4 or 5? 5 strips. So there are total 5 strips here we need to cover. The next chapter which we will be doing revision will be paramagnetism, ferromagnetism. Like जो magnetic metal था basically. वो पढ़ रहा है. My courses is की magnetic वाला chapters सारे खत्म कर देते. Alternating current है या EMI, EM wave ये सब मैं करके basically वो हम revision types में करने हैं. Rest all chapters 11th के मुझे कुछ cover करने हैं, पढ़ने हैं basically. नेक्स्ट इज मतलब हम देख रहे थे कि इलेक्ट्रॉन रोटेट कर रहे हैं एंड एन रोटेशन बना रहे हैं पर सेकेंड. सो दिस इज योर फ्रीक्वेंसी. फ्रीक्वेंसी इज एन. बी नॉट कितना हो जाएगा? यू नॉट 2 अपॉन आई अपॉन आर. तो करंट क्या होता है? बेसिकली करंट इज Q into F. Electron into frequency is current. Remember this formula. Current is equal to Q into F, which is electron charge into frequency. Current is Q into F. So we put charge here as E. Okay, and that's how it becomes E. And because there are n number of terms, okay, so the frequency is n, so it becomes n. That's it. That's it. Remember this. Current. This is very important here. Because if you don't know this, then you will not be able to solve this 2 mark or 1 mark or not. Charge Q is uniformly spread on a thin ring of radius R. Okay. The ring rotates about its axis with a uniform frequency f hertz. The magnitude, again it's a similar question and nothing. In the previous question it was given E. The electron here they have directly said Q. So the current will be replaced by Q into F, and that's how it becomes this. If you knew it, you would have done it. So make sure to add it in your formula list. Okay. Fine. Now these are the cases because अभी हमने देखा कि center of a proper circular loop where we will be getting the formula as mu naught by 2 I upon A. But now here the circle is semicircle. So how will you do for the semicircle? Of course, semicircle is half of the circle. So magnetic field will become half. So this is for the full circle. And इसका अगर half कर दोगे, so this will become for the semicircle. Now they are talking about the quarter. Quarter is 1/4 part. So this becomes 1/4 of that full part. Okay, but if they talk about some art, there you cannot put 1/2, 1/2. There you need to properly substitute alpha upon 2 pi. Okay, that's how you get the arc. So circle is 2 pi and the arc का जो है वो है alpha. So alpha upon 2 pi पार्ट आपको यहाँ पे डालना. Got it? So basically here you put 2 pi by 90. Sorry, pi. Pi upon 2 pi. That's how you got 1/2 here. So alpha upon 2 pi radius. Again, only formula you need to remember from this is this. Alpha by 2 pi. Alpha by 2 pi, alpha by 2 pi. But now, because you know semicircle half है, तो half कर दिया. ये 1/4 है. But इसके अलावा वो 30 degree आ रहा है, तो it's alpha by 2 pi. If you remember this alpha by 2 pi, you remember this automatically. Okay. Find the magnetic field at a point O in the following cases. So they given a semicircle, so it becomes 1/2. Now you need to be conscious about the radius, the direction. So we have this A and we have this B. Okay. So for the A, the direction of the current is this side. For B, the direction of the current is this side. So when A is moving this side, basically this side. Okay, this side. So current here, this side will be inwards. And this will be dot. And opposite one, the direction will be opposite B. क्या होगा? Outwards. This will be a point and this will be dot. This is for B. This is for A. दोनों के लिए कौन सा साइड देखा जाएगा? ये वाला साइड हम देखेंगे. करेक्ट. सो B1 के लिए क्या हो जाएगा? A के लिए क्या हो जाएगा? इट्स इनवर्ड. और B इसके लिए क्रॉस. दैट्स व्हाई गॉट क्रॉस. बट इसमें केस है, इफ यू सी द A रेडियस इज नॉट सेम, यू कैन नॉट जस्ट सिंपली कैंसिल आउट बिकॉज दोनों का मैग्नीट्यूड सेम है. अगर मैग्नीट्यूड सेम होता तो 0 आ जाता. बट यहाँ पर मैग्नीट्यूड सेम है. यहाँ पे जो हमारा A है वो छोटा और जो B है वो बड़ा है. एंड डिस्टेंस है हमारा मैग्नेटिक फील्ड इनवर्सली प्रोपोर्शनल होता है. करेक्ट. तो उसके कारण हमारे पास यहाँ पे क्या हो रहा है कि जो हमारा B1 है विच विल बी ग्रेटर देन B2. इसलिए हम B1 से B2 सब्ट्रैक्ट करते हैं. रिमेंबर. एंड बिकॉज B1 इज द विनर हियर, तो डायरेक्शन भी B1 का ही कंसिडर किया जाएगा. सो बस डायरेक्शन निकाल कर दोनों ऑपोजिट आ रहे हैं क्योंकि कैंसिल 0 नहीं निकल आना है. यहाँ पे दोनों का लेंथ जो डिस्टेंस ऑफ सेम नहीं है. मेक श्योर ऑफ दिस पॉइंट एंड दैट्स हाउ यू गेट हियर आउटवर्ड्स एंड दैट्स हाउ यू गेट दिस. Remember the formula and remember this. Another question we have here is this proper. अजीब से डायग्राम्स बना के क्वेश्चन दे देते हैं और डरा आ जाते हैं. सो क्या बोलूँ तो चलो पढ़िए आप 10 पेज कम से कम पकड़िए. सो ये एक फिगर ऐसा है जिसका ये लेंथ बड़ा है एंड ये लेंथ छोटा है. एंड इसमें डायरेक्शन किसमें जा रहा है दैट इज अगेन वेरी इंपॉर्टेंट. ये वाला इधर जा रहा है, ये वाला इधर जा रहा है. बट ये डायरेक्शन ओके. डायरेक्शंस क्या कंसीडर करना है? ये पॉइंट ए फिर से देख लो, ए छोटा है तो इसका मैग्नेटिक फील्ड ज़्यादा हो जाएगा. तो B1 हमारे पास इस केस में भी ग्रेटर है एंड ये बड़ा. तो पॉइंट 3 और 4 पे अगर मैं देखूँ तो अगर मैं A को यहाँ से निकालूंगी तो ये तो सेम एक्सिस पे आ रहा है तो वो 0 हो जाएगा, ये भी सेम एक्सिस पे आ रहा है तो 0 हो जाएगा, करेक्ट। तो हमें ए का किससे देखना पड़ेगा, इससे एंड इससे, समझे। तो और यहाँ पे हमारे पास ये थीटा थीटा कुछ नहीं है, ये आर है सीधा, करेक्ट। तो इसमें हमारा कैसा होगा, म्यू नॉट बाई 2 आई अपॉन ए अल्फा बाई 2 पाई, बट डायरेक्शन देखना पड़ेगा, ओके। डायरेक्शन का ही सारा खेल है यहाँ पे। अगर मैं डायरेक्शन देखूँ इसके लिए अल्फा बाई 2 पाई और मैंने लिया है ए लेंथ यहाँ तक है, और अगर इसके लिए मैं डायरेक्शन देखूँ इस तरफ है, करेक्ट। ए के लिए जो डायरेक्शन है वो ये है, तो यहाँ के लिए तो इधर को इनवर्स जाएगा और इधर को आउटवर्ड जाएगा, तो ये डॉट होगा और ये क्रॉस होगा, हम कंसीडर क्या करेंगे, डॉट दैट इज आउटवर्ड्स। और बी के लिए ऑपोजिट जा रहा है तो ऑपोजिट कर दो, इसलिए ये इनवर्ड आया, ये आउटवर्ड आया, और जीतेगा कौन, B1 हमारा जीत गया है, इसलिए 1/a से सब्ट्रैक्ट हो रहा है और इसलिए डायरेक्शन भी ए का ही दिया। पता लगा ना, 3 and 4 क्यों भी लेना, सेम एक्सिस पे है तो 0 आ जाएगा। अगेन यहाँ पे सिमिलर फॉर्म, सिमिलर चीज, बट यहाँ पे ए और बी फाइंड करो। यहाँ पे हमारे पास P दिख रहा है मेरे को, एक वायर ऐसा है तो ये एक्सिस पे ही आ गया तो 0 हो जाना चाहिए, P से निकालना है ना, नो ये पॉइंट, हाँ P से निकालना है, सर्कल वाला तो हम निकाल लेंगे, समझ में आता है। दूसरे वाला मेरे को ऐसा नहीं लग रहा है कि भाई टी उसी एक्सिस पे लग रहा है तो 0 लग जाना चाहिए, पता नहीं इन्होंने क्यों इसको इनफाइनाइट वेयर वाला बाय वाला प्लेस में तो उन दोनों को ऐड कर दिया। ये वाला केस देखो, इस केस में ये सेमी है, ये लेफ्ट है, ये आ रहा है भ्रामक, B1 देखते हैं, this is 1, we're talking about the point A, I suppose A is here, तो मुझे लगता नहीं इतना बड़ा क्वेश्चन है ना, और इसको सब पार्ट बन करा सकते हैं, सेमी फाइनाइट 1/2 हो जाएगा, डायरेक्शन माइनस J करना, डायरेक्शन वाला खेल है पाप है। magnetic field at the axis of a circular tube. सर्कुलर है तो 2 पाई कट जाएगा, सॉरी 4 पाई कट जाएगा, 2 आ जाएगा, आई आ जाएगा. बट नाउ दिस इज आता है एक्सेस. बेसिकली हमें ये डिस्टेंस चाहिए. पाइथागोरस थ्योरम लगाएंगे, दिस बिकम्स a square upon a square plus x square upon root 3/2. Find the point on the axis of the loop. B is maximum. Find B maximum. A function. मैग्नेटिक फील्ड कहाँ में मैक्सिमम होगा, यहाँ पे हमारा एक्स मिनिमम होगा. एक्स मिनिमम कहाँ पे होगा, सेंटर पे. और अगर आप सेंटर पे आ जाओगे, all this झमेला goes off in a really like this, जो already studied before. The graph becomes the center पे मैक्सिमम है, उसके अलावा नीचे आ रहा है. अगर एक लूप की जगह एन हो तो एन आ जाएगा, याद रखना. अब है ए स्केल. दिस इज एन alternate way to find B, useful for symmetric problems. This says B dot dn is equal to mu naught I. So it means कि अगर मैं क्लोज लूप के अराउंड इंटीग्रल फाइंड कर लूँ मैग्नेटिक का, तो यू गेट द नेट करंट इनसाइड. दैट्स इट. You find the line integral of B around the closed loop. You get the net current inside. अगर करंट बाहर आ रहा है, एक बाहर आ रहा है, एक अंदर जा रहा है, तो इसके करंट डायरेक्शन इस तरफ होगी और इसके करंट डायरेक्शन इस तरफ होगी. You know this, which formula is this? 2I upon A, finite वाला, no, oh sorry, infinite वाला. वाला सिलेंड्रिकल. मुझे सच में मन करता है कि मैं सो जाऊँ. गाइस क्या मैं सो जाऊँ, मैं सोने लगी हूँ सीरियसली. हाउ मच टॉपिक कवर्ड. ओके, हेलो सिलेंड्रिकल वाला कर लेते हैं. सोलेनॉइड एंड टोरॉइड जो मेरे को नहीं आता है ना, वो है मोशन of charged particles. उसमें तो वो stability बहुत बड़ा, इससे मेरे को भाई बहुत भारी भरकम कंफ्यूजन होता है. ओके.